So we'll just give it a few minutes until everybody joins, and then I'll start. So 7:05, I'll start. Hello, can everybody hear me okay? Could you let me know in the chat? Perfect. Okay, so for today, I was planning on doing two seminars and they're being recorded. But given the fact that there's like only four of you here, I was gonna like run through the notes like from unit 1 to 3 and then cover units 4 to 6 tomorrow. But since there's only four of you, I think it would be better if I just like kind of asked you guys like, is there something specific I should cover from units 1 to 3 that is there something specific from units 1 to 3 that you would like me to cover, or like some certain questions that you guys have? Anything like that? Just let me know in the chat if there is. Question 3 in the midterm. Okay, are you talking about the midterm that I showed off last time? Oh, the one you did this fall. Could you maybe if you want, you can unmute yourself and ask me, or you could type it in the chat. Either one's fine. But yeah, just let me know what the question was, and I can try to do my best to answer it. Okay, so I'll just give you like a few seconds. But I see a few more people have like kind of trickled in. So that's good. Um, yeah. So basically, my plan today, and sorry if I don't check the chat the entire time. I'm also like just using my browser, I guess. Um, but um, I'm going to look at some of the notes. So unit 1 is pretty typically like fairly easy. I kind of want to say, because it just kind of is, because it's more of like an introductory chapter. It's not really consisting of anything. Oh, perfect. Thank you for that. I will download that. Okay. All right, and then I can just share my screen. Which I will do. So can everybody see my screen? Let me just go look in the chat. Yep. Okay. Cool. So let's see. Okay. So you had a question. So this is how the midterm was presented, eh? Okay. Interesting. Okay. So let's see. In this question, you will be asked, is this the question, by the way? Just making sure. Yeah, okay, cool. Okay. In this question, you will be asked to draw the memory model as it would appear while running one of your functions. You will not be marked on the formatting of your memory model drawing, but you need to clearly show the types, which boxes are inside and outside of functions in each of. Yeah, okay, yeah, 3A and B are one question. Yeah, I got it. Multiple parts, yeah. So which boxes are inside slash outside of functions, the locker numbers slash memory addresses of this each box. Okay, cool. So draw an example of the memory model as it would appear just before returning from the final call to add student in the following series of operations. I see. Add students is, oh, it's in question 2. Okay, cool. Let me go take a look at that. Oh, these are all kind of linked together, aren't they? Okay. So I guess I'll run from the beginning. So student, define. Okay, so you have three structures: a student, which contains a student number, and assignments, which is just an array of floats. Um, student node in the linked list where like data is a pointer to a student struct class containing 6-letter long course code and a linked list of student nodes. Okay, that makes sense. Create student creates a new student with student X who has Y assignment marks, all set initially to 0. Create course creates a new course with course code X containing a linked list of students. Each students will have Y assignments. Set grades. Set student X's grades. Assignment Y grade to be Z. Okay, I see. Assignment number Y Z to be Z. Add student X to course Y. Students may be added in any order. Add student X to course Y. Students may be added in any order. Yeah, okay. And this one, blah, blah, blah. Memory model. Okay. So I want to ask you, like, what's the thing you don't quite understand? Just because, like, to cover this question, it would take me a long time since I'm on the laptop. So maybe if there's like something I could answer, that would be good. Or like maybe if there's some particular function call in here that you were struggling with, maybe I can help you with that, like how the memory model would look. Could you let me know, Alfred?
Hello.
Yep, I can hear you.
Okay. So basically, in the one that he marks,
Mm-hmm.
it doesn't really like give the correct answer, but it just says like the memory model reasonably formatted, and the prompt has minimal correct parts. Like that's all the comments I get. So I don't really understand like the basically I don't really understand the question actually. The like was
Okay.
really asking. Yeah.
Oh, the question. Okay, okay, cool, cool, cool. Um, yeah, I could see how this takes a really long time just because like, yeah, these are quite a bit of like, it's like quite a lot to think about. So create a course code. So just off like, and forgive me if I get like some stuff wrong just because like, or like some stuff like slightly incorrect just because I'm like looking back and forth, but class is a 6-letter course code. Um, 6-letter course code, and a linked list of student nodes. Okay, cool. So, oh, that's interesting. So when you create a course code with code like whatever this course code is, and having one assignment, that means that I believe that in your class, you need to create a box that is just of a type class, and it needs to create a course. It needs to create a course code, like variable, like it's so like a char array, for example. And then I guess it would also have to have a number containing how many assignments the class actually has, so like an int. So that's like for starters. Then create a student number with 1, 2, 3. So likewise, another box where you have just a box of type student with their like number, which is just given in the function call, and then assignments, which an array of floats the assignment and assignments, which should be initialized to 0 if I'm correct upon like the first call, because when you create a students, you initially set it to 0. So likewise, you do all of that, but then here when you're setting student numbers 123 assignment mark to be 90, so assignment mark to be 90. So I think then in that float array, you have to put 90 in there. Like you have to kind of like append it. So in this case, you might have to use like malloc or like to dynamically reallocate the array. So it's like bigger since it might be initialized to like a size of 0 instead of a size of like 1 or like multiple, like the array containing the number of assignments will like the length of it will be 0 initially maybe, so you need to like redo it, allocate the memory for it. Add student number 123 to the course. So that's relatively easy because in course code you should have a head student node pointer. um so that should point to, so this student should be in a student node, and that student node, that pointer should be the head pointer in this object, or sorry, structure in the memory module. create student number 789. So it's the same thing as the second one, set 789. So that's also the same as the third one. And then add student 789. Okay, so then here for this last one, it's almost the same thing, except you have to traverse the linked list in course code because now there's one pointer. So you would just do something like head.next is equal to the student node pointer of 789. That's like basically it. To be honest, just because I just don't want to spend like too much time on just like one topic. So if you want, if my explanation wasn't clear enough, here I dropped it in last time, but I'll just drop it in again. Toronto. So feel free to email me like whenever you want, and I'll try to get back to you. We could even like schedule some time to talk, just because like I'm relatively free. Like I'm still on work terms, so I'm like working 9 to 5. But like if you have little questions here and there, I'm like more than happy to help out. So I hope, did I like somewhat do a decent job of explaining this question to you, like maybe so you get it better? Alfred, did I do an okay job? We can talk about it later too if you're still confused. More about the connection between 3A and 3B. Oh, okay, cool. So what did 3A actually? The types. So what they want you to show is just the types of all the memory boxes. So everything on the top left corner of the box, if I'm not mistaken, that's where you usually put the type. Or actually, sorry, it's at the bottom actually, I believe. The top left is like the name of the box. The bottom left, or like you could do bottom right, is like the type of the memory boxes. Which boxes are inside / outside of functions? Okay, yeah. So that's very interesting. So, oh, okay, I see. So I think yeah, that's actually very important. The second one, and then the locker number / memory addresses. So the locker number / memory addresses of each box, these are like very arbitrary. Like you can just create your own memory addresses. It could be like 130 to 140 you use for your addresses. It can be anything you want. The reason why the boxes are inside and outside of the functions is because you need to remember that so like let's look at some of these functions. Create a course code with ABCA001. So there's a create course function. There's a create a student number function. Actually, yeah, sorry, create student, create course, set grade, and add student. So the reason they're asking you to kind of show which memory boxes are in which functions is because we're gonna obviously assume that all of these functions are called from the main function, right? So when we're using set grade, we're actually just passing in the pointer of the student node or the student. It could honestly be either. I'd prefer the student node just because it's nice and packaged. It looks well. But when you're passing in the pointer to the set grade thing, you're not actually declaring anything in the array, and you're not actually like returning anything new. You're just setting like a value. So technically speaking, there should be nothing in this set grade like memory box in like the set grade function. Any memory box that the set grade function has, like it literally shouldn't have any, because it has the parameters, yeah, sure, but it shouldn't have anything else because you're not declaring anything new. Same way with add student. It's set grade and add student are actually like very similar. They're just setting a certain value to a certain value. So these obviously have the parameters, but they don't have anything else. Create student and create course are declaring something new because it's taking a new student. So it's taking a number and it's taking an assignment mark. It's allocating something new, which is a student struct. And then you could also technically say, you could also eventually also create the student node in this create student. So that's why you have more boxes in these, like in this function, than like these two. These you just have the parameter memory boxes. This one, you have the 2 parameter memory boxes plus a student memory box plus maybe also a student node memory box as well. Same thing with create course. You're given a course code, which is X, then a Y, which is like an int, and then you need to also create a new course. So that's a new memory box. So things like, and then you might also have to maybe create a class. I don't think you do, but like since I just like kind of read this question really quick, but so these two functions would have like more memory boxes than these other two because you're actually allocating for something new in here. And then you're eventually isn't the real student node created in the calloc function? I typically isn't the real student node created in the calloc function. Do you mean like yes, but and that create student only creates a pointer of that node created in the calloc function. Yes, but the calloc function is called in the create student function. So technically you could think of, so since the calloc function is being called within the create student function, that memory box is within the create student function. You know what I mean? Yeah. So that's like kind of that. Yeah, this is definitely like a tough question. Like it seems like reasonably difficult, but it also seems very fair. So that's like kind of my explanation of it. You just have to kind of remember like where you're using malloc calloc and where you're like initializing new variables, things like that, or new structs. But actually, does anybody have any questions from this midterm? Like while we have it open, like anybody else? Anybody at all? So would everybody be good with if I just went over unit 1, 2, and then 3 as well, just like very briefly? What's the difference between calloc and malloc? I believe that malloc, hmm, actually, calloc and malloc. Give me 1 second. I have my notes. It's been a while since I took A48, so kind of forgot, to be honest. Oh, okay, I see. So the difference between calloc and malloc is simply, I think calloc can actually declare multiple blocks of memory for a variable. So I think if you wanted like an array, you could use calloc, and then if you wanted like a single block of memory or a single memory box, you use malloc. And then also it says the malloc function, so it initializes that pointer as like a garbage value before you have to like go in and set your values itself, while like the memory block allocated by like calloc is always initialized to 0, so its actual value at the start before you set any like variables within the structure, it's 0 to begin with. But yeah, that's like something you could Google up. I'm sorry, like I had to Google that because it's been, so this question, for this question, calloc is better for making the array. Yeah, yeah, yeah. You would definitely be right about that. Yeah, for sure. Definitely. Uh, but if nobody else has like any other questions, do you mind if I run through like units 1, 2, 3? Just because yeah, yeah, go ahead, Scum then. Sorry if I cut you off there. Yes, because you can, yes, because you set the array, because like actually in C, like when you actually like declare arrays, pointers and array, like the syntax, I guess you could say, are like interchangeable. So you can use like you can use like array syntax technically with pointers in a way. But yeah, you're right. You would set the array as a pointer and then use calloc to allocate the required memory. Yeah, you're absolutely right. Okay, cool. So I'm going to go over like if everybody's good with it, I'm gonna go over unit 1s, 2, and 3, just because I just want to like have it as record because like I'm recording this. So if anybody has like some question about it, but I'm gonna try my best to like kind of skim over unit 1 just because it's like reading for you guys. It's not really like code that you have to kind of like understand. So I'll kind of skim through all of this. So da, da, da. Right. So when you typically, I think you guys are already kind of up to date with this, but I'll just say it anyways. Like the way your assignments work and whenever you write code and see is like you're basically splitting your code into functions, and then the mother of all your code is like the main function where you call everything else. That's basically kind of the gist of it. Um, and then yeah, so basically everything starts from main, and you have to return it in from the main function, so on and so forth. So yeah, you can comment, blah, blah, blah. You have these data types supported by C, int, float slash doubles, chars, and void, which is like no data type. Um, Variable declarations. This is how you call a function. Yeah, yeah, yeah. We're all good. All good there. Right, so you can use like GCC to compile it and run your code. So you would use GCC, the file name, and then you could also use, and then like by default that'll produce something called a.exe, or you could specify the output executable with -o, and then you can call it whatever you want. So you can try. You guys can actually try some of these exercises because you know, who knows, you might be rusty. Um, so that's fine. So yeah, if you have compiler errors, you can Google it. That's universal for every issue when it comes to computer science. Um, so yeah, printf, there are a few things you should remember. It's just like these things where when you're using variables and strings, you use the like the -d and -f to specify. You have to tell C like, because when it tries to read that variable, it doesn't necessarily know if it's an integer, if it's a string, if it's like whatever. So you have to tell it like, hey, this is a dash, this is an integer. So I specify that with %d, so on and so forth for strings, chars, floats, floating point, yeah, oh, with scientific notation, and pointers, yeah. And then you also have these symbols: new line, print a tab. This is the escape character, so you can actually put a slash in a string, and then you can also use a %, I guess, as well. But this stuff is, oh, this meeting will end in 10 minutes. Okay, yeah, that's fine. So basically, this meeting is going to end in 10 minutes. Let me think. Could one of you maybe drop your emails in the chat so I can email you a new Zoom link, and then you could make that post on Piazza as well, if you don't mind? Just because I want to like keep going and cover as much as I can. Alfred, are you there? Could you give me your email address? That'd be great. But I'll just keep going. So thank you. Appreciate that. So I'll get that. I'll just call. Yep. So yeah, so this is just printing stuff. These are some exercises you can cite. This is a good exercise. Basic loops, yeah, like the for loop. So you initialize your variable that you're like looping by. You initialize the condition that the loop will run in, and then you initialize also something that is run every single time the loop executes. So in this case, I equals I plus 1, or I plus equals 1. Yeah, so this kind of better goes into it. Another variation, so you can actually use for loops to iterate over linked lists. Even like that's how like you can get very creative. Like you don't have to just limit yourself to numbers. So that's just like some food for thought. Yeah, so while loops also somewhat like a bit more simpler. It just basically loops while this condition is true. And then if you want to break out of a loop, you can do something. You can use something called exit loop. Um, but yeah, conditional state, so if else statements. So this code executes if this condition is true, else it does this, it runs this code. Uh, these are some logical operators. So this is for or, this is for and this is for not. I'm really rushing over this because I'm assuming everybody kind of up to speed. So yeah, that looks good. So we look good there. Oh, so we can keep going. Um, I actually might end the meeting in 7 minutes because like today was more of an introductory like sort of uh seminar just because I want to like knock off all the like easy stuff out of the way. But we'll see. If anything, I might just do unit 3 tomorrow. Uh, and try to find some like get a Zoom premium account or something tomorrow and like go on for like 2 hours. But this is just introducing the memory module. Everything has like numbered boxes and the boxes are ordered. Very simple. Um, so this is kind of how your memory memory model would look like. Sorry about that. So yeah, you have the name and then you have the type. That's always really important. Please remember that every single function has a return type, like a box specifically meant for a return. That's very important. A lot of people like screw that up just because they don't think of it. Uh, so yeah, these are function declarations. So this is your return type. This is your name. These are your parameters. Very easy stuff. Yep. So you should also remember that when something is returned from a function, every memory module in that function now gets deallocated and it's like basically garbage. So now it's up to like that memory can now be used. So you have to remember that like you can't initialize a point, like you have to make sure like when you're out like initializing things and returning variables, you have to be careful that you still actually have access to them when you're back into main, because it might, if it was like declared in here, when you return it, it might just become garbage because it's stored in here. So you have to be careful. You have to use things like pointers, etc. um yep. So these are just, oh yeah, global variables, that's declared outside of the main function, so they can be used in any function. I will say this, if let's say x is here, right? If x was being used also as a parameter in square, then the x inside the square function would be the one provided into the parameter. It wouldn't be the global variables. So like parameters take precedence over global variables. I don't think that's actually a question I asked when in Paco's class one, so I don't think it's really covered in the notes. I have a question from A3. uh, Question is A3. I'm assuming you've submitted A3. Yes. Okay. How about, can you email me after? Because I want to check with Brian to make sure I can answer that, just to be sure. But yeah, I'd be happy to. You have my email. Okay, perfect. Um, but yeah. So these are going more into types. I kind of want to trust you guys to like read this stuff on your own, because I kind of want to just go over like BSTs, adjacency matrix, big O, and then just APIs tomorrow. That's like the biggest thing. So obviously we have pointers that point to variables, and then this is the syntax to access the actual value or reassign the actual value. So you can use this syntax to reassign a pointer the variable's value that the pointer points to. Um, but yeah, that's basically it for unit 2. We've already somewhat gone over linked lists and stuff. I will say this: if anybody wants, like, I have some decent resources that you could access. So I have like I have a link to a previous midterm I might be able to provide to you, and I have like some really good notes too. So like that I've like gotten from people at Amax. They're not mine. I'm not claiming them as my own. So if everybody can like drop their email in the thing, I'd be happy to send them to you if you want them. So Alfred, I'll send them to you just because you've already shared your email. But in terms of that, I'm going to reserve units 4, 5, 6, and then maybe a little bit of 3 um, for tomorrow. Okay, thank you guys. Just because I'm not feeling too well today, and I wanna like I want you guys to kind of come with questions tomorrow. Just because, to be quite honest, I can't like really, answer every question or like go over the entire thing. I'd rather just answer like questions specific, just because I think that's more helpful for you guys. But did you guys like at least learn something from today? I know it wasn't as long as I liked it to be. This Zoom thing is meeting time really handicapped me. I thought because I did it with a uni email, I'd get like premium, but apparently not. But like, are you guys good with today? Feel free to email me. You have my email. I'll email you guys the resources. This will also go up on YouTube. So is tomorrow's meeting, so you can check it out. I highly recommend you go check out my midterm review seminar too, because I go like pretty in depth into linked lists there. I'm actually considering not covering linked lists, like unless somebody asks me a question specifically to linked list, then I'll answer it. But like I'm not gonna like of my own like time like cover linked list, just because I've covered it a decent amount, and these notes I have like really go in depth into linked list. So yeah. But is everybody good with that? Did everybody like kind of get something from today? I hope you learned something. But yeah. So I'm going to end the meeting now, and what I'll do is first I'll try to get all of your um, emails, and then I'll also get I'll send you guys the stuff, the notes, and then I'll also post this on YouTube. But so thanks guys for coming today. Had fun. Hope you guys learned something, and I'll see you tomorrow. Hopefully Brian post the Zoom link a little earlier, just because I think that's why we quite didn't have as many people today. So hopefully tomorrow we get some more people. Thank you. Have a good night, guys. Thanks Alfred. Thanks Shijun. Thanks Hai. Thanks everyone. Have a good night.